We got radicals. And the reason we call it a radical is we have this little symbol here. So math is a lot of notation.
Yeah.
And this is a notation that just means the square root of something. Okay, so it's a little different from what we're looking at. And so some of the skill sets we've learned before will seem like you can't apply them because you have this new notation. But it turns out a lot of them are exactly the same. So we're going to actually look at first, I'm going to try to find radicals that are the same. Really, this question is asking us is to simplify, which means we have to apply, it's called distributive property. You guys probably called it like first terms and inside terms and last terms, some type of multiplication. So we can do that, but then there's a little bit more to it. Like, what can we combine when we do it? One thing that might be helpful is, if you guys ever written a let statement before, a let statement, what this allows us to do, it allows us to change the way things are looked at on the page.
Yeah.
So for instance, root 2, it is a number, but it's like extremely long number, so we don't actually write it out. Otherwise, it gets too cumbersome to write. But even root 2, if that's new to me, that's visually difficult. I'm like, I don't really know how to use this notation. We can simplify it for ourselves, apply a bunch of the laws we know, and then we can change it back after.
Okay.
So I'm going to do something like this. I'm going to say let A equal root 2. Okay? And root 2 is not the only root. There's actually this other root here. Okay? And what I'll do is I'll quickly highlight what we got root 2. Hey, I got a root 2 over here. And then we have root 5. Okay, so there's just 2 roots in this question.
Yeah.
So I'll put 2 let statements. I'll also say let the letter B equal root 5. Okay? So now when we go to write it, we're going to rewrite the question, and we have bracket a quarter. And instead of root 2, I'm just going to write the letter A. Okay? Maybe that'll be a little easier for us to look at. Plus 1/2, and we're going to write the letter B instead, because we've now let root 5 equal root B. Okay? So still same question, but we've just changed the variables a little so that they're a little more visually appealing. It looks like something I've maybe seen before in math. Plus 1/6 of the letter A. Okay. Okay, that's good. My roots are gone. Still the same question. I got to apply this distributive property. So distributive property, sometimes they write it as FOIL. Have you ever heard it as that? F-I-O.
First, outer, inner.
Yeah, that's it. So we're going to look at our first terms here. We're going to multiply. Now, this is an entire term, even though, pardon me, there's a coefficient and a variable. That's one term.
Yeah.
And this is the first term in the other one. So I have A times B. Well, A times B is nothing I can simplify. So I know that part's just going to be AB. I'm just going to end up writing them beside each other.
Oh, yeah.
I can do the fractions, though. I got to remember my fraction rules. I'll write them out to start. Technically this. So really what we did was we wrote 1/3 times 1/4 times A times B. I actually didn't really simplify anything. I just put it all together.
Yeah.
That's the first step of our first terms. And we'll do the second terms, and then we'll simplify. So we're going to go like step by step, nice and slow when we do it. Outside terms. So outside terms, I'll change the color here, will be this term and this term.
Yeah.
Same concept. We have 1/4, and here we have a 1/6. So those are going to be multiplied, and we'll talk about our fraction rules. But I also have A times A. I can simplify that.
A squared.
Yeah, that's right. So already it's something that, hey, this is a little nicer. I can work with that piece, okay? We can do our inside terms. That would be 1/2 and 1/3. So we'll write those out too. We got 1/2 times 1/3. And then we have B times B. There's another one we can work with. We have B squared. So at least a little bit of simplification. And then finally, we have our last terms here. So the last one in both of the brackets. Yellow's a little hard to see, but 1/2 times 1/6. And then we have that AB again. A, B. Okay? Yellow's a little hard, but we'll simplify this. So let's go down and take a look at our next line. So fractional rules. Here's my question. I got to multiply fractions. What are the rules for multiplying fractions? Well, rules for multiplying fraction look like this. If we have 1/3 times 1/4, you multiply the numerators by each other, like that, and the denominators by each other. So on the top, we get 1 times 1. That's simple.
Yep.
And then 3 times 4, 12. There you go. So we've simplified the coefficient. We have 1/12 times A times B. Okay, and we'll see. Maybe that AB will change into something as we move along once we put our radicals back in.
Yeah.
We take a look at the second term. Same idea. 1 times 1 gives us 1. And then 4 times 6. That's going to give us 24.
Yep.
Okay. A squared we've already worked with. That's nice. So I'll move a little quicker since it's the same process. We're just repeating it twice. So now we do 1/2 times 1/3. That's going to give us a 1/6 and B squared. And we have 1/2 times a 6th. That's going to give us a 12th again times AB. Okay. So This is good. Do I have any like terms? Can you see any like terms here?
1 over 12 AB and
Yeah,
the other side.
exactly. So those are a pair of like terms right here. So I can actually do more simplification. So this AB, and again, even that looks a little tricky. Think of it like this. If we had 1x plus 1x. Well, 1x plus 1x, I actually can just write it as 2x. I take the coefficients and I just add them together. That's essentially what's happening here. I just have to add these two coefficients together. The variables won't change. It'll still be an AB. So we're going to still write our AB, but I have to add my fractions. So I got to go back again. Fraction rules that I know. Now, luckily, this one, I have already a common denominator. Had I not, I would have had to change it. So here, the denominator never changes when we add fractions, and the top is just adding the two. So we get 2 over 12. I can actually reduce that.
1 over 6.
Yeah, very good. So we got that part done. And now we have 1/24. I'm just bringing down the rest of it, okay? Plus 1/6. Okay. Now, if I look through this closely, do I have any like terms? This is an AB. This is an A squared. This is a B squared. I don't have any like terms. So I actually can't simplify any farther.
No
This is as simple as possible. Yeah, and I have fractions. That's fine. I can leave it as fractions. So my question now becomes, am I done? And I got to think back to the original question.
The radicals.
The radicals. I got to put them back in. Now, I can technically just plug them back in. It's good practice to write it again, to say, don't forget that I said let A equal root 2 and let B equal root 5. So this way we can now plug these things back in, okay? So let's see if we remember now. I'm going to take anything that's an A, I'm going to replace with root 2. And anything, I have another color, yellow, here we go. Anything that's a B, I'm going to replace with root 5. Oops, highlighted the wrong thing. Okay, so we're going to just plug those back in. And after a while, you'll get faster at this process where you don't have to do each step one at a time. But it's good to see it. That way you can always look back at it in your notes. We still have 1/6. Now the A becomes root 2, so I'm going to write root 2. And then the B becomes root 5. Okay, now technically this is multiplication. We're going to talk about that piece after. I'm just going to finish the rest of it.
Okay.
Plus 1 over 24, and I get root 2 squared. Okay? Plus 1 over 6, root 5 squared. Okay, let's take a look at this. First thing is, it turns out with radicals, you can multiply the radicals. Okay, and you can multiply the bases and keep the exponent the same. Okay, technically a radical can be written like this. I can actually write it like this. It's technically an exponent of a half. These two things are equal. Okay, so I can start applying my exponent laws, but it might be just easier to remember that I can simplify this by just multiplying what's underneath and keeping the radical. So my next one would look like this. What is 2 times 5? 2 times 5 is 10. And I just keep the root on top of it. Okay, and that's a simplification, that piece. So now I have root 10. Over here, I have 2, I have square root of 2 squared.
Cancel each other out.
That's it. Those are opposite operations. They cancel each other out, so we're just left with actually the number 2 here. All right, and same concept in the next one. We have a 6. We're going to cancel out. We're just left with 5. So there's still multiplication in that piece. Okay. So if we look through here, I have 1/6 times root 10. I can technically simplify this farther. I could say root 10 over 6, but there's nothing wrong with leaving it this way. It really depends on your teacher's preferences. If you're trying to reduce the number of symbols in the final question, something like that. I'll say, we can say 1/6 times root 10. It's actually the same as writing this. And the reason for that is fraction multiplication again. I can technically make anything a fraction. So root 10, I can make a fraction. I just put it over 1. And I multiply the numerators and denominators. Well, 1 times root 10. Yeah, there you go. So we can do that. It's completely up to your teacher whether or not they find it of importance, okay? We'll do that just because it is sometimes common practice, okay? Here, 2 times 1 over 24. This is the same idea. We're multiplying fractions again. I go 2 times 1 on top. I get 2. 24 times 1, 24. So I have 2 over 24. Can I reduce that, do you think?
1 over 12.
That's it. 1 over 12. Same thing with this one here. What is that going to become? You know?
It's just going to be 5 over 6.
Yeah, very good. This is good. We're really close to the end here. I have a bunch of fractions, and I have one radical. I'm going to have addition. Are these like terms? tricky to see. It's tricky to tell.
Maybe the bottom, the sixes that are same denominator.
Okay, we got same denominators here. Those could be it. Cool, but we have a radical. That sometimes looks different.
Yeah.
When we talk about like terms in math, we're actually talking about variables attached to things. Okay, so if there was a variable in here, like the letter X or Y or Z or A, we're looking for like terms. If none of those are there, these are actually called constants.
Yeah.
Constants are all like terms. They're all just numbers. So the real question is, can I add numbers together? Yeah, I can add any number together. It's completely fine. In fact, to make this simpler, I could find out the square root of 10. Let's find out. Hey Google, what's the square root of 10? 3 something.
Square root of 10 is 3.162.
There you go. 3.162, and there's way more to it. I could write that in. It just becomes cumbersome. It's this really long decimal on top of a fraction. That's why we leave it as a radical. It's actually algebraically easier to work with.
Yeah. My teacher says like if it can't get squared and it's a decimal, then just
Leave it. Yeah, and once you become familiar with it, you'll actually agree. You'll go, well, actually, this is a lot easier to work with than other these long decimals. So technically, I can add. Whoops, that's the wrong button. There you go. I can add all of these together. All of these are like terms. They're all constant numbers. Mm-hmm. So in order to add fractions together, I need common denominators.
Yeah.
Okay. Now this one will be simple. I'm gonna make this 12 is a common denominator. It's a common multiple of 6.
Mm-hmm.
So now I can multiply both the top and the bottom.
Yeah.
That works. This one looks a little odder. Sometimes becomes confusing with the radical. What does that become? Well, when you write it with the radical, you just put that number in front of it. And this just means multiplication. So I say 2 root 10.
Oh, okay.
That's it. There's nothing to simplify. We just put it in front. Almost like it's another, it's like a coefficient and a variable again. But in this case, there's no variable. It's actually a number, okay? We have 6. We have 6 over here. Oops, sorry, I lied. It's not a 6.
12.
12, very good. Plus 1 over 12 plus 10 over 12. Now this is 3 separate terms. I can technically write this all as one big fraction at this point. I can say this is all over 12. And then all I have to do is simplify the top.
Yeah.
1 plus 10, that's 11.
Mm-hmm.
Okay, 11 plus 2 root 10. So here's the question. Can I actually put these together?
Can't you do like, for the 10, can't you do like 5 times 2?
Sure, I can split that up. Can I find the roots of any of those numbers though?
No.
Not easily. I mean, like we said
Yeah,
before.
decimal, but
Yeah. So technically, again, we can find this. This is 2 times this number becomes 6-ish. And then plus 11 is 17 something. And this is 17 something over 12. And you could find that to be 1 something. But then we get a really long decimal.
But that's like the simplest.
Yeah.
okay.
This way here is the simplest way to roll. This has been simplified. I can't go any farther. This is our simplest version of it.
Mm-hmm.
Okay? But always remember, I can technically take this farther. I can make this a single number. It's when working with radicals, sometimes students get confused with variables and radicals. Radicals are just representations. They're not variables. We can make them into numbers. We just choose not to.
Yeah.
If this had been the letter A, well, yeah, this is as far as we can go because we don't know what A is in this case. Okay? Okay. So that's...